Alright, day 9. We are going to be using the rational root theorem, and we will not be using a calculator to find the zeros of these functions. But for these first four, we're not actually finding the actual zeros of the functions. We're finding the possible rational zeros of the function. And according to the rational root theorem, the possible zeros will be of the form C over L. All right, they usually use P and Q, but I'm using C and L because the all of the numerators are going to be factors of the constant term, which in this case is 16. All of the denominators will be factors of the leading coefficient, which in this case is 1. So all of my numerators are coming from the 16, okay? But the factors of 16 are 1, 2, 4, 8, and 16. So these are all the possible numerators. The denominators have to come from 1 because that's the leading coefficient. Well, obviously 1 is the only possible denominator. That means the possible roots, the possible rational roots anyway, are going to be all of these numerators over this one denominator. And so that means plus or minus these same numbers, right? It's basically going to be just the 1, 2, 4, 8, and 16. But they are all plus or minus. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. All right? Because these are all over 1, and we don't really write over 1. So, well, looking at all of these have a leading coefficient of 1. Okay? So for that reason, all of these are going to wind up being factors of the constant term on the end. Okay, so the factors of 18 are 1, all right, so it's plus or minus 1, plus or minus 2, that goes into 18, plus or minus 3, not 4, because 4 doesn't go into 18, 5 doesn't go, 6 goes into 18, not 7 or 8, but 9 goes into 18. And then 18 itself. Okay? If we had any other denominator other than 1, I'd have to worry about all the fractions that you could make by using that denominator. But since the denominator is 1, this is it. All right? We basically just use the 18. Okay? So same thing for this one. Because the denominators will all be 1, we're just going to look at the 24. So factors of 24, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, not 5, plus or minus 6, not 7, plus or minus 8, not 9, not 10, not 11, plus or minus 12. Okay? Once you get past the halfway mark, because 12 is half of 24, then you're pretty much done except for the number itself. Okay, so these will be all the possible rational roots of function h. All right, similarly, one more time. We can just look at the 20 since the leading coefficient is 1. So the possible rationals are plus or minus 1, plus or minus 2, not 3, that doesn't go in, plus or minus 4, plus or minus 5, not 6, not 7, not 8, not 9, plus or minus 10. That's the halfway mark, so then it'll be plus or minus 20. So these are the possible rational roots for function f. Okay? So that's just that's what you do if I say what are the possible rational zeros or rational roots, especially if I specifically say using the rational root theorem. Now this next problem is all about using synthetic division to decide if a number is a zero or not. Okay, and we are going to show all of our work and keep all of our work hanging around. So we're basically going to do synthetic division 4 times. Okay, so starting with the -3. Okay, I think I need to zoom in because I need to write kind of small. So there's my -3. Now be careful. Notice this one has a missing term. It doesn't have an x squared term. So when we do synthetic, we're going to have to include a 0. So this will be 1, 0, -9, and 3 for the coefficients. Okay, so bring that down. So that'll be -3, -3, that'll be +9, that'll be 0, that'll be 0, that'll be 3. So if -3 was a 0, then I would have gotten 0. So -3 is not a 0 of this particular one. Okay, so I keep going. And let's see. I tried -3. How about -1? So I do the same thing again. 1, 0, -9, 3. Okay, so that's -1, it's -1, it's +1, it's -8, it's +8, that's 11. So that one did not work. I did not get 0. Alright, so I'll try it again with +1. Okay, so 1, 0, -9, 3. Okay, so that's 1, it's 1, that's 1. Just making sure, man. So that's -8. So that's -8. So that's -5. So that one didn't work either. Alright, so now we'll try 3. Okay, so that's 1, so that's 3, so that's 3, so that's 9, so that's 0, so that's 0, so that's 3. Alright, so that didn't work either. So that tells me that none of these are actually zeros. None of these 4 are actually zeros of this particular function. Okay, so we'll just record that. Alright, so for number 8, it's none. Okay, let's see what happens with number 9. We're supposed to check the same 4 numbers. Okay, so here we go. So once again, we will check -3. So what we have here, we've got 1, see 4, 3, 2, 1, 0. Nothing's missing. Alright, just making sure we did everything right. Okay, so 1, 3, -7, -27, -18. Okay, so that is negative 3, that's 0, so that's 0, so that's negative 7, so that's 21. Okay, so that's negative 6, so that is 18. Oh look, we have a winner! Ding ding ding! Okay, so I'm just going to start my list up here. So negative 3 is a 0. Let's see, how did they word this? Alright, which of the following are zeros? So I'll just put the zeros in a box. So negative 3 is 1 so far. But we have to check all 4 of these values. Okay, negative 3, negative 1, 1, and 3. Okay, so there's negative 3, so let's do negative 1. Okay, so that's negative 1, so that's 2. Alright, so that's negative 2, so that's negative 9. So that's positive 9. So that's negative 18. So that is positive 18, so that's 0. Oh, we have another winner. So negative 1 is also a 0. Okay, let's check the other 2. Okay, so now we need to check positive 1. Okay, so that's 1, so that's 4. So that's 4, so that's negative 3. So that's negative 3, so that's negative 30. So that's negative 30, so this is negative 48. So that's a fail. Okay, so that means 1 is not 1. Okay, so I will check the last one. We'll check positive 3. Okay. So that's 3, so that's 6. So that's 18, so that's 11. So that's 33. So that's 6. So that is 18, so that is 0. And we have a third winner, 3. Okay, so I'll add that to my list. So out of the 4 that we were given, these 3 turned out to be zeros. Okay, so that is it that's how you do 8 and 9. So this one, none of them worked. Yeah, it makes me nervous when none of them work. That makes me fear that I did something wrong. Anyway, okay, on to this. Looking at this graph, we're supposed to factor and find all roots of the function. And we're going to do the whole listing of the factors and the roots thing. So let's look at this graph and see if we can identify any zeros right now. Well, it looks like we have a 0 right here at negative 1. And it looks like we have a 1 right here. Now notice this is counting by 2's. Which makes me wonder, does that mean that that is actually negative 2? Yes. Oh, and this is going by 10s. Okay, I really don't like it when they change the scale like this. It's sort of vague. But anyway, I was wrong at first. This 2, so that means the x-axis is counting by 2's. So this is actually a negative 2 that we're looking at. Okay, and this is actually a positive 4. So we have a negative 2, all right, and a positive 4 because we're counting by 2's apparently. Okay, so on my list of roots, I'm going to go ahead and put negative 2 and positive 4. So far that gives me factors of x plus 2 and x minus 4. Now, this is a cubic, so I'm missing a root, all right? There's just one missing. And I can tell it's right there. I just don't know what it is, but it should be something between negative 3 and negative 2, all right? It's right there. But I will use synthetic division and stuff to find it. All right, so let's go ahead and use the zeros that we have. So I'm going to use the negative 2 for sure. So here we go. So we've got this negative 2, and then the coefficients are 1, 1, negative 14, and negative 24. Okay. All right, so that's going to be negative 2, negative 1, positive 2, negative 12, positive 24, and of course 0. Okay, so now it's time to factor this. So putting the variables back in, this is x squared minus x minus 12. And we should be able to factor this pretty easily. So this is going to factor, x squared, of course, is x times x. 12 is either 3 times 4 or 2 times 6 or 1 times 12. But we need a middle of negative 1. So I'm thinking the 3 and 4 are going to do that for us. So inner, we have 3x. Outer, we have 4x. To get a negative 1, I need a positive 3 and a negative 4. So there's my positive 3, and there's my negative 4. And positive times negative is negative, so there I just factored it. Okay, now look, this x minus 4 is the x minus 4 that I already found. All right, this is not a repeated root, this is the same root. Because so far we only used the negative 2. Okay, so this, we knew we were going to see a 4 show up, and here it is, right here. So we really only need to include the one additional root of, the factor of x plus 3, which is going to give me a root of negative 3. Oh yeah, by the way, over here, for a second there I was saying, oh, it's going to be something between negative 2 and negative 3. But I was messing up because here again they're counting by 2's. So I should have been saying it's something between negative 2 and negative 4, and turns out to be exactly in the middle, which of course was negative 3. Okay, halfway between negative 2 and negative 4. So it does make sense, even though I was messing up the graph a little bit. And we know we're done. It's a cubic, so there should be 3 zeros in all, and here they are, we're done. Okay, let's look at the next one. Okay, same type of deal all over again. This time they are counting by 1's, thank you. And this is going to be a little extra easy because all 3 zeros are visible right on the graph. Okay, we've got a negative 1, and we've got a positive 1, and we've got a 2. Those are the zeros. Okay, so just write them down. So what did I say? We have a negative 1, and we have a positive 1, and we have a 2. So as far as the factors, that's going to translate into x plus 1, and x minus 1, and x minus 2. That's it. Okay, that was a little bit easy peasy lemon squeezy. By the way, speaking of the rational root theorem, if we were going to talk about the possible zeros of this function, all right, this is just extra information. The possibles, all right, just talking about those possible zeros from before, the possible zeros would have come from this 2, okay, since the leading coefficient here is 1 for the denominator. So the possible zeros would have just been plus or minus 1 and plus or minus 2. Well, the possible rational zeros. Meaning there could be other ones that are imaginary or have a square root in it or something. But check it out. Plus or minus 1 and 2. Notice how all of these are among these very few possible zeros. Just as expected. All right, I'm just trying to make a few connections for you guys. All right, moving on. Okay, so for all of these problems, we have to do this without using a calculator. I actually don't mind if you use a 4-function calculator, but do not use a TI 30 or a graphing calculator. Okay, and I would prefer if you show all of your work similar to what we did when we did this stuff. See how I'm showing all the synthetic and I'm keeping it? I'm not don't just erase it. All right, keep it, show your work. All right, so here we go. Now look, in terms of the possible zeros, all right, the rational root theorem is not going to help us too much because 30 has so many possible roots. That's 1, 2, 3, not 4, but 5, 6, okay, 15. All right. Oh, I forgot about 10. If I want to go in order, I better go back. 10 goes into 30, 15, all right, that's the halfway mark, so I can skip to 30. And all of these are plus or minus. So there's a bunch of possibilities, and I really hope that, you know, by the time I try 1, -1, 2, -2, 3, that's 6 tries. So I'm really hoping that it's going to be within those first 6. Okay, and I recommend going in order. Do 1, -1, 2, -2, 3, -3, 5, -5. Go in order like that. And if I'm making up the problem, I will always try to make it turn out so that you will find one within the first 6. Okay, so go in order, or you could be here all day. So let's see what we've got. So first I will try 1. Okay, so I've got 1, -8, -23, and 30. Okay. So this is going to give me 1 and -7, and then -7, so that's -30. Times 1 is -30. Oh, look at that! First one we tried, we got 0. So we already found one of our zeros is 1. So let's go ahead and put that on our list. So our first 0 is 1, which means we have a factor of x minus 1. So we are on our way. We've got 1 down, 2 to go. Now, once I get down to a trinomial, I'm not going to keep guessing. As soon as I got a trinomial, I'm going to go ahead and put my variables back in, and I'm either going to factor or use the quadratic formula. So this will become x squared minus 7x minus 30. Okay, so will this factor? Let's see. X squared is x times x. 30 is many things, but for example, we've got, let's see, 3 times I'm sorry, not 3 times. 5 times 6 is 30. Okay, can I get 7 out of that? No. Okay, what else? We've got 3 times 10 is 30. Oh, that's looking good. Let's go with the 3 and the 10. Now, inner, I've got 3x, don't you know? Outer, I've got 10x. I'm trying to get negative 7, so positive 3 and negative 10 will do it. So there's my positive 3, there's my negative 10. And a positive times a negative is negative, so got 'em. This is how you factor this trinomial. So x plus 3, x minus 10. Okay, so x plus 3, x minus 10. Okay, so this is going to translate into a 0 of negative 3, and this will give me a 0 of positive 10. Now, this was a cubic, degree 3, so I was expecting 3 zeros, so I know I've got them all. So that's it for that problem. Okay, that's it, number 14. All right, I didn't really need all that space, but I was ready, man. All right, number 15. Let's start with the possibles. I'm doing this like above. Okay. The possible zeros are, okay, looking at this 12, all right, and again, the leading coefficient is 1, so in practical terms, we're looking at this 12, and I'm thinking plus or minus 1, 2, 3, 4, 6, 12. All right, that's a lot of possibles, but again, if I'm making up the problem, I'm going to make sure if you go in order, positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, you're going to find one within the first 3. I mean, the first 6. Hopefully, like last time we found it, the first one we tried. So it all averages out to being like within the first 3 tries or so. Okay, anyway, might as well get started. So let's start with positive 1. All right, in fact, you're always going to start with positive 1 and negative 1 every time. Okay, so here we go. Positive 1. And let's see, here we have 1, 2, negative 11, and negative 12. All right, I'm leaving myself lots of space to do more. So here I bring this down. So that's going to be 1, so that's 3, so that's 3, so that's negative 8, so that's negative 8, so that's negative 20, so that's a fail. So I will go on to negative 1. Okay, so here we go again. So that'll be negative 1, and 1, and negative 1, and negative 12. And negative 12 times negative 1 is positive 12. And we have a winner, okay? It only took 2 guesses, so that's not too bad. Once we have a trinomial, we will go ahead and put the variables back in. X squared plus x minus 12. Oh, let's write this down immediately. So we have another 0. Wait, not another 0. We have our first 0, which is negative 1. So let's put that on our chart. So negative 1. That gives us a factor of x plus 1. Okay, always write that down immediately when you find it so you don't forget. Okay, now let's try to factor this. Okay, so this would be x times x. I'm thinking 3 times 4. Now I need a positive 1 middle, so negative 3 and positive 4 will do it. And a negative times a positive is a negative, so we got it. So x minus 3, x plus 4. All right, so there it is, factored completely. And here I have another 0 of 3. and this is giving me a 0 of negative 4. All right, this was a cubic, so since I have all three, I know I'm done. So I can move on. Okay, number 16. Okay, those possibles, man. Let's talk about the possibles. All right, well, 40 is divisible by a whole bunch of stuff, so I may not even list all the possibles, but we know that it's going to be plus or minus 1, plus or minus 2. 3 does not go in, so we would skip that if we had to. But then that we get up to plus or minus 4, plus or minus 5, not 6, not 7, but plus or minus 8, not 9, but plus or minus 10. Plus or minus 20 and 40. Okay, so those are the possibles. It's a lot of possibles. But again, if I'm making the problem, you'll get it within the first 6. All right? So the trick is to make sure you skip the 3, because you'd be wasting your time on the 3, because that's not one of the possibles. Okay, so hopefully it won't take us all 6, but be emotionally prepared for it to take 6. All right, because it might. You never know. All right, so let's go in order. So always start with 1 and negative 1. So I've got 1, negative 7, 2, and 40. Okay, so it's going to be 1, it's negative 6, it's negative 6, that is negative 4, and that is negative 4. So this is 36, so that's a fail. All right, let's try negative 1. Okay, 1, negative 7, 2, 40. Okay, so that's going to be negative 1, so that'll be negative 8, so that'll be 8, so that'll be 10, so that'll be negative 10, so that'll be 30. Alright, so that is also a fail. Alright, do I have room for 3 right over here? I think I do. So now I'm supposed to go and try positive 2. Okay. So I'm just going to squeeze it in down here. So here we go. Now I'm going to try positive 2. So 1, negative 7, 2, 40. So that'll be 2, negative 5, negative 10. That'll be negative 8. That'll be negative 16. So that'll be 24. So that is another fail. Okay, so next comes negative 2. Just going down the order. All right, so let's try negative 2. I feel like I should draw a line right here. All right, 1, negative 7, 2, 40. Wait, that's one number. Let me make sure it's clear. This is 40. Okay. All right, this is our 4th attempt. All right, so I'm really hoping we get it pretty soon. Okay, so that's going to be negative 2. That's going to be negative 9. It's going to be 18. That's going to be 20. 20 times negative 2 is negative 40. Finally, on our 4th try, we found 1. Okay, so negative 2 is a 0. let's write that down immediately. Negative 2 is a 0, which means we have a factor of x plus 2. Alright, so let's see if we can factor this. If not, we will use the quadratic formula. So putting the variables back in, we have x squared minus 9x plus 20. Alright, I have a good feeling about this. X squared is going to be x times x. 20 is either going to be, 4 times 5, or 2 times 10, or 1 times 20. I'm liking 2 times 10? No. 4 times 5. I'm liking 4 times 5 because of the 9. So if I have 4 times 5, then inner I have 4x. Outer I have 5x. I'm trying to get negative 9, so I really need both of these to be negative. Negative, negative. And a negative times a negative is a positive, so bingo. So x minus 4, x minus 5. Okay, which translates into zeros of positive 4 and positive 5. And again, this was a cubic, so we know there should be 3. So we have all 3, so we're done. Alright, so much for number 16. Alright, that took 4 guesses. That was the longest one. How many more of these we got? Oh, is this the last one? Yeah, did we really do 3? 14, 15, 16. Alright, number 17, last one. Okay, the possibles. The possibles are, alright, again, plus or minus 1, 2, 3, 4, 6, 9, 18, 36. Ooh, time for lunch. Time for lunch. But I'm going to finish this problem. Okay, so we're just going to go in order. This list of possibles didn't really help us because it's 1, 2, 3, 4. This is really not helping us. Anyway, let's just start guessing and checking. So starting with 1. So let's see, I've got 1, 9, negative 4, negative 36. So that's 1 times 1 is 1, that's 10, that's 10, that's 6, times 1, that's 6, that's negative 30, that's a fail. Alright, let's try negative 1. So that's negative 1. That's 8. That's negative 8. That's negative 12. That's positive 12. Alright, that is negative 24. Another fail. So I go on to positive 2. Alright, it's positive 2. So that'll be 2, 11, 22. Alright, this will be 38. No, what am I talking about? Not 38, I mean 18. And 2 times 18 is 36. Hooray! Okay, so I found my first 0. It is 2. Put it on the list. Alright, which means I have a factor of x minus 2. Okay, let's see if we can factor this. Otherwise, we'll have to use the quadratic formula. x squared plus 11x plus 18. Let's see what we got. X squared is x times x. 18, how about 2 times 9? Positive and positive, all right? Because 2 and 9 make 11. So there it is. X plus 2 times x plus 9. So there's your factored form, and your zeros are -2 and -9. That is the end of this lesson. All right, hopefully you did not touch your calculator, because there's likely to be part of the test where you have to do all of this without using a calculator. All right, but for now we are out. I will see you on the next video.